Hello everyone, welcome back to my YouTube channel SGKmistry lectures. In this video, I'll be explaining about what are polymers, what are the different types of polymerization reactions, that is especially condensation polymerization and addition polymerization, and also the synthesis of various types of polymers coming under these categories of condensation and addition polymerization. So first of all, what are polymers? What do you mean by polymers? Polymers are nothing but they are macro-sized molecules. That is, they are large molecules with a very high molecular weight. That is, they are made up of very small units and thus they result in a large molecules which are called as polymers. So this polymers word is derived such that if you split this word into two different terms, poly is nothing but many, mer is nothing but unit. So many units join together to form the polymers. That's why we call these molecules as polymers, because they are formed from many smaller units. So these smaller units are referred to as monomers. So monomers join together to form polymers. So next, how are these polymers formed? The polymers are formed by a particular process called as polymerization. That is, the process by which the monomers join together by different mechanisms to give rise to polymers is called as polymerization. In this polymerization, there are two important categories, that is condensation polymerization, which you also call it as step growth polymerization, as well as the other type of polymerization is addition polymerization, which is also called as chain growth polymerization. So first let me tell what is the basic difference between these two types of polymerization reactions. In condensation polymerization, as the name indicates, condensation is nothing but a condensation reaction involves the losing of small molecules during the reaction progress. So here also, in this polymerization reaction, small molecules such as water or alcohol or such small molecules like water or small molecular weight alcohols will be removed out during the process of condensation polymerization. This type of polymerization is mainly occurring in case of bifunctional molecules, that is, which have two functional groups minimum, or you can say polyfunctional molecules which have different types of functional groups, active functional groups, which will react with the other molecules to form the polymers. So this type of polymerization reaction is called as condensation reaction, where condensation polymerization in particular, where the different functional groups of the monomers react with the losing of different small molecular weight molecules to result in the formation of the large polymer. Here coming on to the next type of polymerization, that is addition polymerization. Here, as the name indicates, the monomers add with each other to form the large polymer. Mainly, this type of polymerization is exhibited by alkenes or dienes and their substituted products. So these type of reactants, these type of monomers, mainly alkenes or dienes or substituted alkenes or substituted dienes, they react with each other by addition reaction to give rise to the polymers. So here this polymerization takes place with the increase in the chain length, and that's why we call it as chain growth polymerization, or in common words I can also call it as addition polymerization, since the addition reaction is taking place for the formation of the polymer in this case. Now, in this video, I'll be explaining in detail about the different types of polymers that are synthesized by making use of this condensation polymerization or step growth polymerization. So first class of molecules, the important class of polymers coming under this category of condensation polymers, by which the condensation polymerization is done in order to produce these molecules, are polyamides. As the name indicates, polyamides are nothing but the polymers which consist of the amide linkages in these molecules. So amide linkage is nothing but NH, CO, or you can also call it as CONH. So this bond I can particularly show it to N. So here from this functional group itself, it is very clear that this has to be formed by the combination of the COOH, that is carboxylic group, COOH group, and the NH2, that is amino group. So when they combine with each other by the losing of water molecule, they will give rise to this amide linkage. So mainly when the different monomers are joined together by amide linkages to give the polymer, then such type of polymers are called as polyamides. So here mainly we have the amide linkages, that is CONH, or you can also call it as, you can write it this way, NHCO, based on the placement of the monomers. So this type of polymers can be formed by the condensation of diamines with dicarboxylic acids. That is, when a particular monomer has two carboxylic groups on either side, or a particular monomer has two amino groups on either side, then the NH2 and COOH group will combine with each other, and the condensation reaction takes place by the losing of water molecule to give the amide linkage. So here you know that whenever it is carboxylic group, there is COOH, and when there is amino group, there is NH2. So this H and OH will combine together, and this will be removed off as water molecule to give the CONH linkage or the amide linkage. This can also, the polyamides can also be formed by making use of amino acids. So we know that amino acids are nothing but these molecules have both functional groups, that is acid as well as amino group. Because of that they have the name amino acids. So by the combination of amino acids also you can get polyamides, and also by making use of cyclic amides, that is caprolactams, you can produce this polyamides. So now let us see which are the different polyamides, important polyamides, which are mainly used in synthetic chemistry as synthetic fibers. So now let us see the few different types of polymers coming under this category. Now coming on to the two important polyamides, that is nylon 6,6 and nylon 6, how they are produced and what are the different properties of these different types of nylons. So first coming on to nylon 6,6. So why do you call this as nylon 6,6, and what are the different monomers that are used for the preparation of this nylon 6,6? Nylon 6,6 is produced by making use of two monomers, that is hexamethylene diamine and adipic acid. So methylene group, we know that it is CH2. So hexa is nothing but 6 times hexamethylene diamine. So it is a bifunctional monomer and diamine. So there are two amino groups on either sides. So this is the formula for hexamethylene diamine. And adipic acid. Adipic acid is a bifunctional, that is dicarboxylic acid. It has two carboxylic acid groups, and adipic acid, it has CH2 4 times methylene groups, and COOH groups are on either sides. Okay, so here you can see in the two monomers, here you can count the number of carbon atoms. Here CH2 6 times, so there are 6 carbon atoms. Again in adipic acid, here there are 4 carbon atoms because there are 4 CH2 groups and 2 carbon atoms of the COOH groups. Because of this, you can see that in both these monomers there are 6 carbon atoms. That's why we call it as nylon 6,6. So now these both undergo condensation reaction with the removal of water molecule. So you know that here there is one NH2 group, here there is a COOH group. So as I've already explained, whenever there is a NH2 group and a COOH group, condensation reaction can take place. So here the OH group of the COOH group and one of the hydrogens of the NH2 can be removed off as water molecule. So we can get the polymer. So here also the polymerization takes place in both the sides continuously. So here also one of the hydrogen is lost by the NH2 group to form the condensation product by the losing of water molecule. So we have CH2 6 times. Here we have the NH CO bond, that is the amide linkage, and then we have CH2 4 times CO, and this continues. So here we have N times. So this will go on continuing. These monomers will completely add with one another continuously to form the product. So each of the monomer here goes on undergoing polymerization on both the sides to give ultimately the polymer, which is written like this, that is nylon 6,6. Okay. So next, coming on to nylon 6, the preparation of nylon 6. Nylon 6 is produced by making use of caprolactam. The caprolactam is the monomer that is used. So first step involves the hydrolysis of caprolactam, which will result in the open chain structure. Once the open chain product is produced, the amino group of the open chain product goes and attacks the other caprolactam molecules to finally give the polymerized product. So first let us write the reaction that is involved here. So caprolactam is a cyclic amide. So it has 5 methylene groups or 5 CH2 groups and the amide linkage that is present all within one cyclic structure. Caprolactam is also a cyclic amide. So first what happens in the first step, the hydrolysis takes place. So hydrolysis, we know that it is the reaction with water for the breakage of bonds. So here at high temperature the reaction takes place between 533 to 577 Kelvin. So at a very high temperature the reaction is carried out to give the open chain structure. So finally, as I've already told, once the open chain compound is produced, the NH2 group will further attack on the other caprolactam molecules to give the polymer. So let me write the structure of the polymer. NH, so CH2 5 times, CO N times. So here the polymerization reaction takes place to give finally the nylon 6 as the product. So what are the uses of this nylon? So nylon is very important synthetic fiber. So it is insoluble in most of the common solvents. So it is very resistant to solubility in different types of solvents. It has a very good strength and also it absorbs very less moisture. So these both polymers, that is nylon 6,6 as well as nylon 6, are very important synthetic fibers because of all these properties. So this is about the polyamides, which are an important class of polymers which come under condensation polymers. So thank you for watching the video. I'll be continuing with this topic of polyesters in my next video. Thank you.